And we should be live. Welcome, everybody. This is Service Mesh Academy. I'm joined by Michele Mancioppiof from Dash0. We will be talking about OpenTelemetry and linkerd. As we have said on many occasions, this is where to go and find all the Service Mesh Academy stuff on GitHub. And if you want to ask questions or heckle or comment or whatever, which we dearly hope you will, the best place to do that is the workshops channel on the linkerd community Slack. So welcome, Michele. Thanks for being here. I apologize for butchering your name every time I say it, since I'm sure I'm getting it wrong.
It's actually fine. Thanks for having me.
Thanks for being here. Let's go ahead and dive into this. I'm not sure, we have a fair amount of stuff to cover. And it's going to be a little different this time around from some of our other ones in that we will go through and talk about observability and OpenTelemetry and why you should care about these things. But an awful lot of what we're doing in this particular Service Mesh Academy is going to be letting Michele talk about some of the details of all this distributed tracing stuff rather than having me blather about stuff. And then we will do a demo involving hopefully some really cool stuff. So off we go. If you want to follow along, as we hope you will, there's the URL. Once again, the QR code goes to that URL for Service Mesh Academy. It's the Service Mesh Academy repo and the OpenTelemetry and linkerd directory within it. One very, very important caveat is that a lot of the time we show up and say, oh, we're going to use Bell, but you can use Edge. No, for this one, you must be using Edge 25.2.1, which came out yesterday. It may or may not be the case that while we were prepping for this workshop, we found some stuff that we needed to fix. And so there's a new Edge with shiny new things in it that are actually really cool. Obviously, when Buoyant Enterprise for Linkerd 2.18 comes out, it will include this. Later edges than 25.2.1, if you're watching this sometime in the future, they will also have all of this goodness. It will work fine. Just remember, 25.2.1 is the earliest release that this will work on. I will be showing this running on a K3D cluster on my laptop and feeding information out to Dash0. I have tested this on a Cibo cluster out in the cloud. It worked great. I am pretty sure Michele's done it with Minikube. You should be fine, whatever kind of cluster you want. So, go nuts. This is the complete list, I think, of things that, tools that I use in the demo. Yeah, rock on. And if you use the QR code to go to the repo for this demo, then it will check to make sure that you have these. And if you don't have them, it will tell you where to get them. So you don't actually have to, you can screenshot the slide if you want, but you don't have to. There's code to do that for you. And on that note, I think what we're going to do here is hand it over to Michele so as to start hearing about observability. Or observe what?
Observe what? That is actually the reaction that I get when I go and explain people not in the know, not in the industry, what to do for a living. And it usually goes like this. When you go and talk about observability, especially in Europe, you go and ask them, hey, how do you know that your application is running correctly? There is a bunch of confused stares. People start looking at the others, and then one brave soul will come up and say, nobody's screaming at me.
Yeah, that resonates. I'm not going to lie.
It is, I appreciate the honesty. I think ideally you should know at least as fast as your customers do when something is not exactly in the best shape. There is also a certain amount of confusion about what observability exactly entails. It's a very long word that we don't use in the normal lingo, but here's the trick. There is a certain amount of buzz in the industry about observability being entirely different from everything we have done before. That is at a very minute level of difference compared to the whole thing that ideally you monitor your applications really well. There are, depending who you speak to, some particular definitions of observability. There is a significant amount of confusion by pretty much the entire APM industry, and some the more vintage monitoring tools claims that, of course, now they do observability too. There is also, and this I found profoundly fascinating, there are some very, very interesting differences in terms of geography. What you see here on the right-hand side is that in Equatorial Guinea, they know exactly what's up. They know exactly what observability is, and other countries are catching up. I actually have a version of this breakdown from 2021, and it was a really stark contrast between the west side of the world talking about observability more than monitoring, and the right side of the world talking more monitoring than observability. I find it very, very fascinating.
I'm
And
going to be spending the rest of the day wondering what's going on in Equatorial Guinea.
I think they know what's up.
Clearly.
That's simple as that. So observability, it's you can use the word monitoring for it. It's fine. Nobody, the observability police is not out to get you. Some people that are thinking monitoring mostly a matter of metrics may raise an eyebrow, but in reality, probably the most easiest way that you can think about is that monitoring is the action that you do to ensure that your application is observable. Observability is a property of an application. It's not an action that you do. Of course, here there would be if you get the right people at KubeCon on the floor, there's going to be a huge argument, but that is probably the easiest way to explain to you, your colleagues, your teammates, your managers, what observability is about. And now the next step is, okay, another O word, OpenTelemetry. What's that? OpenTelemetry is a very fascinating project. It is the second largest project in the Cloud Native Computing Foundation. It's actually overtaking Kubernetes in some categories, like the amount of commits, if I recall correctly.
Wow.
It does a lot of things, and it's equally fascinating to talk about what it does not do. So OpenTelemetry is a set of specifications, a set of pretty high-quality implementations of ways of collecting telemetry for applications. And if you think about telemetry, it's mostly at the moment distributed tracing, logs, metrics, but there are also things coming up like production profiling. There is real user monitoring for websites and mobile with different levels of maturity. So it's a very encompassing project for most of your telemetry collection needs. What it isn't, it's not proprietary. There is no single vendor driving it. It's actually effective a sort of alliance of sorts by the overwhelming majority of the observability industry, in a way that maybe the closest that you can think about is Kubernetes itself. It's not a query language. It doesn't have an OpenTelemetry query language. It's there is some work going on in the CNCF tag observability for something of the kind, but it's still early days. It's not the implementation of a backend. You may have heard of Jaeger and Flynn, it will come up. It's a pretty cool open source project for collecting traces and visualizing them, but there are others that are either open core or actual open source, like, for example, Zipkin used to be very popular a little bit ago. OpenTelemetry is not feature complete. There is new stuff, new ideas, new approaches going on the whole time. And for somebody like me that has been in the monitoring / observability industry for more than a decade, it's cool. It's cool to see that we are not done yet, and there is always something better to do. And it's absolutely not boring, but it's not boring mostly in the good way. To be
Oh,
honest,
good.
excitement in software tends to be bad, but when a project is cool and that is what you're excited about, then it's fine. Now, we've spoken about the kind of telemetry that OpenTelemetry allows you to collect, and those in the lingo are known as signals. And you probably have heard of most of them. Distributed tracing is probably the most solid, the best understood part of OpenTelemetry and the most widely adopted. It's effectively kind of the signature signal of OpenTelemetry in a sense, and it's going to be front and center in what we're doing today in this webinar. Then there are metrics. There is OpenTelemetry SDKs can allow you to generate metrics like up and down counters. So pretty much the same things that you're already doing with Prometheus. And you can migrate to OpenTelemetry, but also if you actually use Prometheus, the OpenTelemetry collector is able to scrape your Prometheus endpoints and translate those metrics to OpenTelemetry. So if you have a backend that can process OpenTelemetry metrics, you're going to be just fine without having to retool your Prometheus endpoint. Logs and events. Logs are actually called log records, but I would never use that word seriously. It's too long. They're logs. They are. It's a part of the specification that is getting there, so it's usable. I also do not believe that in this decade we're going to see a massive migration of people throwing away their existing log collection infrastructure based on FluentBit, FluentD, Logs Dash, in favor of retooling that entirely on the OpenTelemetry collector. What is more likely is a lot of new setups, new startups, new teams, new projects may start with the OpenTelemetry collector first, and that will be pretty cool.
One of the interesting things about this actually is the idea that you could do metrics without standing up a Prometheus in your cluster, and you could do logging without firing up Fluent and stuff. That the OpenTelemetry collector, and a proper backend to visualize could actually replace all of that. That's kind of a cool idea.
I have every hope that the OpenTelemetry collector is the last observability agent you will ever need to learn. It's worth learning it.
It has been fascinating preparing for this and learning about the OTel collector, yes.
Remember, folks, if it works, don't change it. So endpoints are fine. You can scrape them. Your existing hardened Fluent bit configurations with a bajillion regexes, keep them. Consider the OpenTelemetry collector for the new stuff, because that I'm pretty sure it's pretty future-proof. Now, there is more going on. Profiling is something that has been actively worked on, and it's pretty advanced. You might have heard of the approaches of doing profiling using eBPF. And there is an implementation of a profiler based on eBPF in the OpenTelemetry collector. It's something that I expect will become stable at some point this year. And then it's going to be easier to find out where your bottlenecks are in terms of CPU usage, for some languages, memory allocation, I/O weight, and that way, having good intel on how to improve the latency of your applications. There is the real user monitoring. I have conflicting feelings about the current implementation. There is rework going on. It's usable to some extent, but I don't love the current OpenTelemetry JS bundle. I think it will get better over time. It's usable, and at Dash0, for example, we use it to monitor our own product. There are other options out there as well.
Real user monitoring is hard, let's be honest.
But then again, without knowing what is going on with your end users, do you really know what is the impact of your database exploding?
Nope.
So
not that I have any personal experience, you understand, with anything like that where we didn't realize that a particular problem was causing issues for the real users of the platform.
If anything, I would argue the fact that the level of visibility in what's happening in the front end is usually zero in a lot of organizations where backend is centric, is actually preventing adoption, because the moment you start having a common language between the front-end teams and backend teams, and the backend teams actually have a way of understanding how their problems are affecting actual people, that's a pretty transformative experience for everybody involved.
Yeah, the common language part really, really resonates with me on that one. I can't even tell you how many conversations I've had with people who are stunned to find out that communication is one of the core things that software people have to work on. It's like, yeah, it's really important. It's much more important than writing the code. Being able to communicate with other people is critical.
Yes, I don't want to comment on that. It's true. Every technical problem is at least in part a human problem.
Yeah.
Now, here you see on screen how a rather abstract architecture is in terms of collecting data. On the top left side, you see the way data is generated. So OpenTelemetry, you have SDKs, which are implementations of the OpenTelemetry API. On top of it, you can add auto instrumentations. So the fact that, for example, if you are using Node.js, you could load packages that automatically instrument your code to collect, for example, distributed tracing data and metrics, or add appenders to your Pinot or Winston loggers so that you have the data from your application automatically collected and transmitted to your usually OpenTelemetry collector, which is, you can think of it as the Swiss Army knife of OpenTelemetry. It allows you to collect, transform, and retransmit an incredible variety of formats, way beyond just OpenTelemetry. We spoke Prometheus. There is a Prometheus receiver, which instead of receiving goes out and scrapes stuff, but it's a receiver. You can, it's not only, for example, you can go and collect logs from journald on the OS, or read files with a file log receiver, or go and collect information from a variety of managed services, CloudWatch logs, CloudWatch metrics, Stackdriver, like you name it. Usually there is one way to do it with the collector. And
one of the things that was interesting to me as I learned how the collector worked was the language that it uses for some of its configuration didn't make a lot of sense in the beginning. But once I started realizing that the OTel collector calls anything that will be bringing data to it a receiver, and anything that will be causing the OTel collector to talk to somebody else is an exporter, and anything that the OTel collector is going to do any sort of internal processing was a pipeline,
a
processor, and then a pipeline changed them all together. And that started to make more sense.
Actually, I'm going to do something now that will make Flynn cringe. And I'm going to put on screen something entirely unprepared.
I never do that during SMAs. Never.
No. This thing, hotelbean.io, is a tool that we at Dash0 have donated to the community. It's entirely open source. It was our love letter to the community when we created the company, and we said, okay, let's solve a first observability problem. And then we looked at it. The OpenTelemetry collector is amazing, but it's really hard to configure and to understand what all the processors and receivers do in the scope of pipelines.
Yeah.
And that's how Hotelbean is born. So this tool will allow you to visualize and validate the configuration of a variety of OpenTelemetry collector builds out there. By default, it will actually use a schema to do some syntactical validation. But actually, we keep up with automation on the releases of several builds of the collector, the two community ones, the distro of AWS, Splunk. So you can actually go and validate your configuration against a live collector that just tries to start, reads your configuration. If it doesn't like it, it crashes, and we tell you.
Highly recommended. This was pretty helpful, actually.
Now,
and also we had a question show up in the workshop channel where One of our users there was asking if there were going to be recommended best practices or suggested implementation structures. And okay, there you go. There's your first recommended best practice is you can use OTelBin to find out if your configuration is actually likely to fly. And yeah, highly recommended.
There's also a meta recommendation. If you are getting into OpenTelemetry, and I'm going to talk more about this in part 3, I think, of this talk, you should have an OpenTelemetry collector close to the applications in which you put OpenTelemetry SDKs. It provides you a way to both do, for example, compression of the telemetry, but as well as filtering, transformation, enrichment of telemetry on site before you send it somewhere else. It is probably the best way you have to do, for example, secret reduction. If you leave those pesky credit card numbers in your spam attributes, that's the CISO may want a word. The OpenTelemetry collector is amazing at that. It's great. You can use it to debug stuff. You can use it to multiplex the telemetry you send. One of the beauties of this day and age of telemetry is that since effectively as a community, we seem to have agreed that proprietary telemetry is a bad idea, because it is. More and more backends are actually accepting OTLP. And the OpenTelemetry collector can multiplex. So you can send literally the same data to multiple tools and compare apples to apples, the one that you like best, which is fascinating, also from a vendor perspective. Speaking of vendors, of course, I had to put Dash0 there on the bottom right, because I think is the best way to actually process OpenTelemetry data and make sense out of it. But I may be a tiny little biased. And Flynn, isn't there something missing in this picture?
I think there's something missing, definitely. Yes.
Today,
speaking of shameless plugs, I mean,
that's why people are in this webinar. I think it's fair, right? To see, we're going to talk about how linkerd can actually generate spans and become part of the traces that are being built by your applications over their interactions as a distributed system, and how those can be sent to a local OpenTelemetry collector and then forwarded to Dash0. That is the gist of the matter. All right. So now, next part. Which telemetry do I need? Remember, we discussed a lot of signals: metrics, logs, distributed traces, RAM profiling, blah, blah, blah. Where do you start? Well, that depends very much on what your application looks like, what your systems look like. Although, to be fair, everybody starts with logs, because the first thing you're going to do when debugging your code is to grab that standard output or standard error and put some text into it. That's how logs were born. In my opinion, the kind of telemetry that you need to do a good job of observing your applications depends on their nature. The lower you go, the closer you go to silicon, the more things have to be well understood to actually work at scale. For example, you're not going to make distributed tracing of a hypervisor or a GPU. That is not happening. So there you talk about logs and metrics. The higher you go on the stack, the more diversified it is, the more distribution you have in the system. The closer you are to the user, the less the technology that you deploy is hardened by a variety of other people doing the same. Then you start adding more complex, richer, more difficult signals to understand. For example, when you look at the operating system, nobody is going to trace systemd, but you may use strace or ptrace or pprof in some cases to go and collect information about where your hotspots are, what is consuming all that CPU, why all of a sudden the cat command is burning all my cycles. Then you start going higher. Distribution starts creeping in. The moment you start talking about containerization or serverless, you start adding more and more leaky abstraction layers, unfortunately, to your stack, the more observability you need. Also, the less control you have on the technology underpinning your Java, Node.js, .NET, Go applications, the more observability you need. You cannot SSH into an AWS Lambda function to attach a profiler or to attach a debugger and find out why that thing is taking so long or why the errors are generating. So that is where you need to invest upfront or adopt things like OpenTelemetry to actually collect information that is going to be useful when issues occur. And then the closer you get to the user, the more you start talking about real user monitoring and synthetic monitoring, which is what back in the day we would have called like smoke tests. So is my API working? Is my UI, if I do my playwright test playthrough of the checkout button, does it keep working? And this is pretty much the state of the art of what people do to monitor applications across a variety of stacks in the cloud native world. Now, I get myself some OpenTelemetry. Let's go heavy on the recommendations here. Bad news is there is many ways of getting you some OpenTelemetry, and they depend heavily on what your applications look like. But I'm going to give you a few pointers about it. So, usually, when you talk with most kind of platform teams, they already have a setup in place. They have logging agents. They have some sort of Prometheus, or maybe they're a bit vintage and they're using Graphite. There are ways of collecting metrics and logs about what the operating system is doing, what the orchestration platform is doing. And the biggest gaps tend to be at the level of applications. The best way to start with monitoring your applications is to use auto-instrumentations whenever possible. And OpenTelemetry has comprehensive lists of instrumentations for a variety of runtimes and libraries in there. The Java one, absolutely top-notch. It has like a bajillion libraries that are supported out of the box. .NET Core, it's really good. Node.js, pretty good, except the ESM bits where it can be a bit difficult. Python, it does a lot. And there is, for example, some very cool work going on in terms of monitoring LLMs. Ruby is pretty cool. Erlang, there is an SDK for Erlang.
We just got a question about Swift.
There is an SDK for Swift. There is, if I recall correctly, also a way of doing. So Swift is a language that it's mostly on iOS apps, but you can also use it in the backend, a bit like Node.js, but in reverse. So JavaScript. Yeah. There is something I actually have no experience with that firsthand, sadly.
It's a pretty interesting language in general. It's going to be interesting to see how far it ever penetrates outside Apple, honestly. But
it has been around for a bit. I think in a world with Go, the kind of cloud system languages is. I mean, there is competition. There is Rust. It has the SDK for Rust is a bit earlier than the others. It's relatively recent, but it's usable. And for example, Flynn, I understand that is what you're using in Linkerd, correct?
The Linkerd data plane is entirely Rust, and the control plane is a mixture of Go and Rust, but skewing more towards Rust as we go. So we're going to have to take a look at that.
There is C++. There is an SDK for that. There are also, so those are SDKs without much in the way of auto-instrumentation, because these are effectively compiled languages. Although if you speak with somebody like Go, they're going to tell you, no, there is a runtime. Yes, but you cannot do the things like bytecode instrumentation.
Dirty little secret, people. Every language you've ever worked with that isn't hand-tooled assembler has a runtime.
But if it's a compiled language, you probably don't want to screw with that runtime.
You really, really don't want to screw with it, yeah.
But that doesn't mean that you must go and automatically instrument your applications from beginning to end. There are interesting approaches, like several actually, eBPF-based ones, including a recently announced OpenTelemetry beta for the community OpenTelemetry Go automatic instrumentation. There is actually, if you keep an eye on the Dash0 website, we're going to publish a deep dive. We tried it out. We looked at it. It's interesting. It has some interesting trade-offs in it. So there's a lot going on in terms of automatic instrumentations.
There's one other recommendation or comment that I would make here. So one of the things that I did while I was going through and setting up this thing was I took a look at whether I could easily add OpenTelemetry tracing to the Faces demo application, which is written in Go. And what I learned was that there's a lot of information out there about how you can instrument a Go program and do really cool things, pretty much all of which assumes that you're doing things in a particular way with your HTTP and gRPC servers. That way happens to be the one that, the Go ecosystem has settled on these days as arguably the right way or the popular way. It happens not to be the way Faces is written for various reasons that don't necessarily make a lot of sense anymore. So I haven't finished that because I have to go through and actually refactor Faces to do things the way the rest of the Go ecosystem is expecting, because that will be easier than going and figuring out the nuts and bolts of the instrumentation stuff. But that's, I guess, another recommendation is to, as you're looking at these for manual things, recognize that you may find that they are opinionated about how you implement certain things in your application. And, you may be able to cast about and find one that matches the way you've already done it, or you may decide it's worth just doing some refactoring, as I did.
I think that in my experience, the harder thing about instrumenting an application in Go is not necessarily that the HTTP server that is very unfortunately out of fashion, and it's now a very regrettable bit of technical debt, is the biggest problem. It tends to be the fact that if you have not built your application in a way that propagates the context.context object throughout, then you're going to have broken distributed tracing, because that is the way. And I'm going to give you a very detailed understanding on how distributed tracing actually works. That is the way that from one end of the application to the other, you're going to keep track of which trace this is. So that is usually, like, for example, also the OpenTelemetry Go automatic instrumentation. It will fill for you the HTTP parts and the gRPC parts and the database spans, and I think also some Kafka ones, but it will not do the automatic trace context propagation through your routines.
Yeah, I mean, I don't really want to rat hole around Go, but the seismic shift in Go from not using context explicitly to using context explicitly has a lot of interesting ramifications. But we probably should move on rather than rat holing too much on Go or Rust. Although Rust would be fun.
So now let's talk about the new and exciting way of getting linkerd part of the action, not only from the point of view of networking, but also from the point of view of generating telemetry. And actually, it doesn't depend. There is just one way to do it, and that is what we're going to show you today. Flame, do you want to do this one bit?
Yeah. We haven't talked a whole lot about the background of linkerd in this particular talk, but yes, linkerd is a service mesh. Hopefully many of you coming to Service Mesh Academy might have figured that part out. But remember that the purpose of a service mesh is to add security, reliability, and observability to your application uniformly across the whole thing, ideally without changing your application. We're going to talk about that because distributed tracing is a place where you are going to have to change your application. It has to be instrumented for this. But the point of the mesh is still to assist you with observability. Linkerd does its meshiness stuff. Go ahead. By sticking a proxy next to every one of your application pods and then letting those proxies mediate and measure all of the traffic happening around in the application, which means that Linkerd is in an excellent position to go through and add information that distributed tracing systems like OpenTelemetry can use, because it's already seeing all of the requests going back and forth. And I think, so that is really what we're talking about here, is Linkerd is already in a good place for this. So what do we need to do to tell Linkerd to go ahead and participate in OpenTelemetry to help you out with this? Fortunately, as of Edge 25.2.1, which came out yesterday, that's pretty straightforward.
It is. And I have it on good authority. It will get even better soon. But no pressure, Finn.
Yeah, thanks. Appreciate that. I think there's one more bullet point on this slide that we already talked about. But yeah, you do have to integrate things into your observability setup. It's okay. It's not hard. Go ahead.
As a point of view of a practitioner of observability, the fact that by the proxies taking part in the trace and talking about how they see the two sides of the communication, it actually adds an entire level of nuance about understanding why a request that you think has left a pod didn't arrive on the other. You actually start understanding, okay, did I lose it? Like, did my application actually not send it? Did the other side not receive it? Did the other side not answer it and dropped it to the floor? This is where having distributed tracing with Linkerd in between is like chef kiss. It adds an entire level of understanding about where errors are coming from.
One of the things that's really fun in this job is going through and trying something and getting to the point where you finally get to see it working, and having, just like watching it and going, oh my God, now I get it. And that's particularly fun with this particular one.
Now, how does this work? This
is where I get mocked.
You may be a little heckled. So there is a Jaeger extension, which today we are going to use in an entirely Jaeger-less fashion.
Yeah.
Because we are going to send the data to Dash0 instead. The Jaeger extension actually can do a bunch of things. You can, by default, it will give you a local installation of Jaeger, although it's not the latest and greatest. It's in, I think, in the 1.x range.
It's really old. Don't use it.
If you do want to use Jaeger, try out Jaeger 2.0. Mm-hmm. It's good. It has a built-in OpenTelemetry collector, but that's not the freshest, shall we say. It's version 0.59, while we are at, I think, 116. So we are going to use actually the latest and greatest OpenTelemetry collector, which comes built in the OpenTelemetry demo application.
The history here, the reason it's called the Jaeger extension is actually that its original purpose in life was kind of being a proof of concept of showing how you could integrate Jaeger into a Linkerd setup back in the dawn of time. I don't remember how many years ago it was. It was a long time.
It's at least 5, according to the Git history.
Yeah, it might even be older than that. We are not going to use it that way. The way we are going to use it is we're going to take advantage of the fact that the Linkerd proxies now understand how to natively speak OpenTelemetry. So basically, the only thing we want the Jaeger extension to do is to tell the proxies, please speak OpenTelemetry, send it over to OTel demo, OTel call.otel, right? The OpenTelemetry demos OpenTelemetry collector in the OTel demo namespace on port 4317, which is OTLP over gRPC. And we also need to tell it the service account that destination is using so that Linkerd can properly set up MTLS. And yes, this is not the most elegant thing on the planet right now. We are working to make that better. So stay tuned.
Although I have to say that as somebody that has worked with other companies that did not do observability as a living, I found the enthusiasm and the willingness to improve on OpenTelemetry by the people of Buoyant absolutely refreshing.
Oh, nice. Yeah, there's a lot of stuff that, if it makes Linkerd more operationally simple and better for the users, yeah, we want to do that.
A word to the OpenTelemetry aficionados out there. The proxies are talking gRPC directly. In OpenTelemetry, when you have an exporter, which is also something you can have on the SDK side, that's how the SDK sends data of process. You have either gRPC, and this is what linkerd uses, or you can have two flavors of HTTP depending on the serialization format. So protobuf or JSON. Linkerd does only gRPC to the best of my knowledge, but it's
I
perfectly
think that's
fine.
correct.
It's perfectly fine for different components in your distributed system talk OTLP in different formats because the collector understands them all, and there is no difference in the encoding of the wire format. So it's perfectly fine to have some components report via gRPC, other HTTP. There are other formats in the working. There is a cool idea with using Arrow for putting high amounts of tracing data and metrics and spans into queues and data lakes. So there is that is just an implementation detail. Don't let this turn you off.
Michele, I'm going to go ahead and move us along a bit because we are coming up on 45 minutes and I really want to show people the demo.
All right, let's make a very super quick overview about what happens when you have two applications into pod stocking. From a conceptual level, you have two pods, one sends an HTTP request, one sends an HTTP response. If only if it were actually that simple. You have your applications, your containers, you deploy linkerd. Now you have four processes that collaborate in exchanging one HTTP request. Your application in a container is going to talk to the local proxy. The local proxy will talk with its peer on the other side, which then will forward finally the request to the other application and vice versa for the response.
And of course, when the proxies speak to each other, they're doing MTLS because that's what linkerd does.
When you actually think of it in terms of distributed tracing, all of these four components are going to independently from one another report spans into, in our case, the OpenTelemetry collector. And how do these mythological spans actually look like? You can think of spans as a kind of bit of a log, except it's not about an event, or it's not about an instantaneous event. It's about something that took place over a duration of time. So spans have a start time and have an end time. You subtract the end time and the start time, you have a duration. OpenTelemetry uses nanosecond precise timestamps, so you can be really fine granular on that. A span lives inside your SDK until it's closed, it's ended, after which you have all the metadata you need. Usually the span in the SDK becomes immutable, can no longer be changed, you cannot add additional metadata on it, and it's sent off process for storing and processing to a collector or a backend, or first one, then the other. Spans are related with one another in two ways. Spans belong to a trace. A trace is a collection of one or more spans. And spans are related with one another through parent-child relations. I'm going to give you more details on this very soon because I have a graphical explanation that is better to explain. Spans have names and have attributes. For example, the metadata of which HTTP method you used, which status code you sent or received, and so on and so forth. If you want to know more about how distributed tracing works, we have a pretty cool article on the Dash0 website, and that will infobomb you the way I'm doing, but in a written form. When you actually go and look at the data structure, this is an abstraction of what it looks like. In OTLP, there is OTLP, the wire format of OpenTelemetry. There is a little bit more. There is data about resources also. So where the span is coming from, for example, which pod or in which namespace or which cluster. But this is pretty much the intuition that you must bring with you today. Spans are created as your applications communicate with one another, and you create effectively a tree of spans. From without considering some corner cases, distributed traces Yes, don't get me started there. Distributed traces are effectively trees. And there are these parent-child relations, like in trees, but for technical reasons, the child knows what the parent is, not the other way around.
That was a really important thing as I was looking at some of this stuff, was realizing that that relationship is only one way, and also realizing, as you noted, that the span only gets sent when it is closed. So a lot of eventual consistency here, folks.
That has a caveat. If you don't close your spans, they don't exist in your backend.
Yeah.
If your application crashes, the spans that are currently open, they don't exist in your backend, as well as the ones that were not yet closed but not yet sent of process. Yeah. Here is what you see in the way that, there's a concept called trace context that is what the various implementations of OpenTelemetry collaborate as a sort of pointer that is shared and propagated among them to keep track of which trace it is and what the next parent will be. So the first application is going to start a trace, creates a new trace identifier, creates a span. The span is sent to the linkerd proxy. The linkerd proxy will create two spans, one for the incoming of the request and the other for the outgoing, because they will have, for example, different latencies. It will update the trace context twice. Every time you create a span, you will update the trace context, then send a request. So over the MTLS HTTP request between the proxies, there is going to be a header called the trace parent header using the W3C trace context specification that will actually bring information like which trace it is, what was the last span on the other side, so that the proxy on the right-hand side receives the HTTP request, sees the trace parent header, says, cool, I'm going to trace this, and I'm going to create a span, the parent of which is S3. So the span that came in with trace context. Within the proxy, the trace context is updated because the new span is going to be S4. Updated again when the span is when the request is sent out to the application, and so on and so forth. In a nutshell, the trace context propagates forward. You send it downstream to the people that you issue requests to, and the spans link backwards. Because on the parent side, you're not going to know if the other side is traced. You're not going to know what the idea of that span is. But you propagate forward what your current span is, so the other side says, I continue from there.
The thing I was going to say is that point about HTTP headers and context propagation, that's why you have to instrument the application. If you do not propagate the trace contexts and add new spans and things like that, okay, there are a couple of things the proxies can do, but you're not going to get, it's just not going to work very well. And this is why you have to instrument the application as well.
We're going to talk about this in the gotcha section after the demo.
Yep.
And so if some component in this chain does not do its job properly of instrumenting and updating the trace context, you have this so-called broken trace, meaning that one side that fails to propagate correctly at some point will decide, hey, it's a new trace, and you lose the information about the whole story. And this is the most common issue that newcomers to distributed tracing actually suffer, especially when creating manual instrumentations, that they fail to propagate at some point in their application, and it's different levels of complexity in different languages, and then they end up with traces that are incomplete. So, Flynn, shall we?
Let's shall. All right. This is the demo app that we are using. It's the OpenTelemetry demo app. Shocking, I know. It comes with its own set of application stuff that are all instrumented for OpenTelemetry, and it comes with an OpenTelemetry collector. So we are going to go through and show both what you see without going through and telling Linkerd the right thing to do, and then what you see when you tell Linkerd what to do. So, as always, everybody cross your fingers and off we go. So, important note here. We mentioned earlier, you must be using Edge 25.2.1 for this. Just to say it again. We will be using an OpenTelemetry collector in the cluster, which is definitely a recommended practice. There are things where I guess you could have your application send directly to a collector outside the cluster, but sticking the collector really close to your application turns out to have some useful benefits. It gets to understand more about your Kubernetes setup and things like that. As Michele mentioned, it also gives you a lot of opportunities to do things like scrub data that shouldn't be leaving your cluster, for example, improve latency, give you better breath. I don't know, So it's generally a good idea to do that. We are also going to configure our collector to then go ahead and export data out to -0, continuing our shameless plug for -0 stuff. If you happen to already have some other OpenTelemetry setup, by all means, use it. Awesome. But if you want to try this with -0, you can go to -0.com, get yourself a -0 account. When you do that, on the settings page for your account, you'll be able to find your auth token and your OTLP endpoint, and you will need those as environment variables going forward with this setup. So I have already set up this environment talking to a -0 account, actually talking to one of Michele's -0 accounts, I believe, using OTLP over gRPC. So the first thing we're going to do is we have a totally empty cluster right now, and we are going to install linkerd on it.
By the way, while we're waiting for stuff to install, but besides, I love the installation process of linkerd. I think it's the best.
Note again, Edge 25.2.1. Sorry, go ahead, Michele.
While you're waiting, there is a hopefully pretty interesting article on the dash0.com/blog website about why you need a collector on your Kubernetes cluster to make sure that the metadata of your application are the best they can be.
For people who were actually, sorry. Michele, if you can toss me a link to that,
yes,
I will stick it up on a lower third. For the people who are watching very closely, you will note this linkerd extra install flags thing here. That variable is empty. I am not passing any extra install flags. That is there because yesterday we were having to pass flags to use a brand new shiny just built proxy. You don't need that. So we'll go ahead and get Viz installed there as well. And let's wait for linkerd to be running. And while we're waiting for linkerd check, let me go ahead and stick this up really quickly. That is the article that Michele was just mentioning, best practices for Kubernetes about, really we're talking about resource attributes there, but the simple fact is that some of the best practices that, as described in that article, would be really, really hard to realize without having the collector running in your cluster. So, hey, everybody, run the collector in your cluster. It's a good thing to do.
And since we're waiting for the check, resource attributes are attributes about where the telemetry is coming from. For example, which pod in which cluster. There is at least another type of attributes like the span attributes, which are about the specific request, and that would carry information like which HTTP method, which response status. The resource attributes are probably the most important part of OpenTelemetry that only few people actually get and use well in practice. It's effectively the correct way of having the answer of whether you care or not about an issue. Because if you don't know where it's coming from, you don't understand whether you're going to wake up at 3 a.m. in the morning or wait until the first coffee tomorrow.
Yep. Now, as we install the Hotel demo app here, we are doing something that will look a little bit weird, even though it's not really all that terrible. It definitely looks a little bit weird. There is a Helm chart for the OpenTelemetry demo. but we're not using it directly. What we did instead was to use Helm template to grab all the YAML, and then we went and modified the YAML. Here I'm going to look at our very first deployment in the demo YAML, and I'm going to dump it out as YAML and take a look at it. What we did was we added in the template, we added this annotation, the config.linkerd.io trace collector name. This sets the service name that Linkerd's proxy will hand to OpenTelemetry. And we did it this way so that every Linkerd proxy in the system has a unique name. This turns out to be important. This is another thing that we at Linkerd are going to do better than this. But for right now, you can set this annotation, and if you do not, then you remember how we talked about the way that when a span arrives back at the collector, it has a link to its parent, but it doesn't really have anything else. The service name turns out to be kind of important for making certain that your backend that's doing all the collation of your spans understands where everything is coming from. And as a human, having unique service names for all the proxies just turns the trace from being this mess of twisty little things all alike into something that you look at and go, oh, that's exactly what's happening. And it's really amazing. So, important point for right now. Okay, let's go ahead and get it installed. We're going to create a namespace for it. We will annotate the namespace for Linkerd injection so that everything comes up fully injected. This sed command is me just sticking our auth token and OTLP endpoint into the YAML we're about to use as I apply it to my Kubernetes cluster. And it's done that way because we changed that several times through this demo. So we're just going to sit here and watch for this to come up. But I think that rather than sitting here watching this, let's flip over to the -0 dashboard, Michele, and then hopefully that'll be a more fun thing to watch than my pod thing going on here.
For the record, the fact that you have a collector in the cluster means that there is one place where you need to change where to send the data, which is also a great plus.
Yeah.
So what you're looking at is -0, a very map.
Remind me, if we have a little bit of time, we should actually show the configuration for the hotel collector we're working with, at least a little bit.
It's happening. Data starts flowing.
Woohoo!
And as more services come online, the map will start expanding. More connections will be seen. Now the pods are one after the other coming online. Some communication starts happening. Oh, there is more going on. And eventually we will have a pretty large set of services interacting with one another.
One important thing I want to note here is that this is being populated with data as it arrives at the -0 system. So what's happening is that pods are shifting from initializing to running their init containers to running the actual application. And once the application is running, then they all start spitting data over to -0. And that's what causes this to go on.
Let me zoom out a little more so that we see the network starting developing. Note, the Linkerd proxies are not yet part of the trace that is going to come. We can also do something pretty cool. As data comes in, we start seeing the first errors because only part of the application is up. So, for example, in -0, you have the heat map that tells you how many spans are happening at which point in time, at which bucket of latency, and how many of those are errors. -0 we also love to save you from having to think too hard, if possible, because when the sirens are blaring and the outage is going, you do not really want to have to remember what gRPC status code 4 means. So we peppered our application with all these cute little hints that prevent you from having to go and Google or OpenAI it, ChatGPT it. It's a way to start to help you get to quicker insights. We start seeing the first traces. They're pretty uneventful, as mostly are single components that fail to talk to the others. let me get to a more, yeah, things are settling down now. You see that the latency is going down, the errors are far less seldom. Let's have a look at the map. Stuff is starting to come in, and soon Dash0 will start collect statistics. Oh, something went right. Dash0 will start collecting statistics about the data that is coming in. Here we are having a front-end service that is actually failing to execute correctly. The check is being executed. Soon we'll have a time series that will tell us why. And this is the fact that I asked Dash0 to tell me if the front end is taking in the P99 to take more than 80 milliseconds to answer. And as time will go on, then the front end will get its stuff sorted out, and then the check will resolve.
And at this point, everything is actually up and running. And oh, hey, look, we started to see connections between our various application pods too.
Yeah, this is pretty much the hotel demo application, its final form, to use a Dragon Ball expression. Maybe Flynn, what do you say? Should we spice it up a little bit more?
I think we should. So now that we have our application running at all and getting good stuff going on, well, first I have to apparently reshare my screen for no apparent reason. This is how you know we're doing it live, people. All right, there we go. So, as we were saying, we've got information in Dash0. We have an application that is running and generating spans and linking them together into traces and feeding it all up to our backend, and everything is great. And we don't have any Linkerd information in there at all. So we're going to fix that now. You saw this in the slides already, but just to be clear, we are explicitly turning off the Jaeger functionality. We are explicitly telling the Jaeger extension not to install its own collector. We already have a collector. And we are using the Jaeger extension only to tell the proxies, hey, we want you to speak OpenTelemetry. Specifically, we want you to speak OTLP over gRPC to the Hotel Demo OpenTelemetry collector in the Hotel Demo namespace on port 4317. And we expect you to find the service account named Hotel Demo Hotel Call when you do that. So I shall apply that. And I shall wait for everything to be running, which really amounts to making sure that the injector webhook is running.
As a curiosity, Flynn, I actually failed to ask you during the days we were preparing this. Why do you need a service account?
Service account, in this case, is the thing from which the Hotel Demo, Hotel Collector's MTLS identity is derived. And so what we're really doing here is telling Linkerd, this is the identity that we think your collector will be running, so that if it finds some other identity, it can yell at you. Because if you're feeding span data to the thing, it would be good to know that you're feeding it to the correct thing, right? This is back to the security part. Now, we could go back to the Dash0 dashboard and it would look exactly the same as it did before, because the Linkerd proxies for our Hotel Demo application are still using the old configuration where they were not told to do Jaeger, or sorry, not told by the Jaeger extension to do OTLP. So rather than flip over right now, we're going to do a rollout restart of everything in that namespace. And then once again, we shall, rather than watch this, we shall flip back over and take a look at the Dash0 dashboard, because we should start seeing things change.
By the way, OTLP stands for the OpenTelemetry protocol, not the OpenTelemetry language protocol, as some people have.
I always assumed it was the OpenTelemetry line protocol, personally.
That would have been also a good one.
Yeah, that probably would have been okay.
It is the best way to get data out of the system, but pretty much every SDK that you will use, and of course the OpenTelemetry collector, has exporters for also other formats. Most notably, stuff starts appearing, more things connecting. For example, Jaeger is not only a backend, it actually was also a set of tracers and a protocol.
When I was debugging stuff, I actually told with this demo, I configured things to have the OTel demo open telemetry collector. Oh my God, that is a mouthful. I configured that to actually export to a Jaeger UI that I had installed so that I could watch things with everything being entirely in the cluster before I had figured out how to link it all up with my very own -0 organization. These days, I just use -0, honestly.
I agree. I endorse that statement. Although, again, Jaeger, pretty cool project, good stuff, community driven. It's for doing some local debugging. It's a good start. I endorse -0 if you want to monitor your production.
So what sorts of things are we seeing change on this map? Because we're seeing new things appear.
More nodes come online. For example, we start seeing all these additional nodes called linkerd proxy frontend. Proxy and then the suffix of the name. This is what we have done with the, I want to say config.linkerd.io/trace collector name, Flynn.
I think it might be trace collector service name, but nicely done.
Could be. And as you see, the map changes shape as more things appear in the traces. I want to have a look at a easier, maybe to digest view of what our components are doing, the services at the logical level. This is the resources tabular view in -0, where you find all types of things like services and Kubernetes specific things. We see, for example, the red metrics of our services. We see that the front-end proxy is not doing so great. It has that issue about being too slow. But for example, the linkerd front-end proxy is doing really fine, and the request it's serving is actually serving pretty fast. So you see here how in the different steps of the journey, stuff changes. And from here, we can actually go and see some very deep traces. Let me go and grab something cool. For example, this one looks good. As you see here, this one starts from the front-end web. So we are kind of mocking a web application. So there is something that seems to be like the browser, and it's generating a lot of requests for something downstream. Let me see something with linkerd in place. For example, something slow. Let's go and grab something from here. All right.
I really like the way you can select chunks on the timeline and then zoom into them.
And soon, just by actually hovering over the timeline, you will have the traces filtered automatically.
Oh, nice.
That's at the0, we work really hard to keep improving the UX and make sure that the tool is working with you and not against you when outages are ongoing. And as you see here, as we unfold this very deep tree of spans, you see how, from the service perspective, it's going through different things. So the request from the load generator to the front-end proxy went through the linkerd proxy of the load generator, then into the linkerd proxy of the front-end, then into front-end, then again in the linkerd front-end proxy, because there was an outbound call.
The outbound, yeah.
Which is something that helpfully the span generated by linkerd gives you with the direction attribute, outbound or inbound, and the story keeps unfolding. You also see some interesting things. For example, you see here a span that appears to start before the parent. It did not go back in time. Clocks are not great. Clocks are really difficult. So let me start zooming in a little more. And you go on and on and on. And if we were to find, if stuff started failing, we would actually see how the red went up. So you would see entire chunks where there's entire chunks of red where errors start at the bottom and they propagate upwards. Or in other words, outwards towards your end users. And this is what
actually had a question that might be interesting on this one. Is it possible to visually determine from that -0 when an entire span has not populated correctly? And I've certainly seen cases where I looked at a span before all of it had arrived, or before a trace before all of its span has arrived, and things like that.
I'll give you an example for that. For example, when you go and look at the freshest spans, like the latest and greatest, chances are that we'll find traces where stuff is missing. This did not get lucky enough. Let me scroll. By the way, I'm using the keyboard. We have pretty much throughout the product keyboard-based navigation. So far, one button, I'm in the deepest trace. No, so far I'm not getting luck with that, but it could be that, for example, one of the components is lower than the others in reporting trace data. And then you would see Dash0 telling you that, unfortunately, some spans are missing. That is what happens when you have a span. It has a parent ID, but we haven't received the span with that ID. So it's something that can happen. Distributed tracing is effectively kind of eventually consistent. It also can be, because computers were a mistake, that data is missing at one point or the other, but it's very seldom. The OpenTelemetry SDKs are pretty rugged, not only in terms of their performance overhead, but the assurances of getting the data out as well as possible.
We did see that a couple of points where the way it looked was that we would see something where, instead of seeing that nice, waterfall sort of thing, we would see what looked like a chunk that was way out dented and, kind of looked like it was a sibling instead of a child. And that was usually a representation that a thing had not arrived yet. Then we'd, 30 seconds later, suddenly it would pop into being and everything would be great.
The problem is that fling your cluster is too good.
Yeah, I guess. I mean, yeah.
I always find fascinating, especially when across your distributed system, most of the data happens asynchronously, how latency builds up. So you see where the data comes in, what things are slow, and how things go back. And this gives you a pretty good idea of where to optimize first. Something similar, although it looks a little bit different, and unfortunately I cannot show it to you here because we do not, the OpenTelemetry application doesn't do much in the way of messaging. Actually, let me do something quick. I will go and look for spans of kind consumer. These are spans that are about messaging. But yeah, I don't see the other side of the thing. It's this part is missing in the application. Probably it's not instrumented correctly. If we had the other side, then you would see very large gaps between the span when the message is queued in and when the message is received on the other side.
Gotcha.
Most of the communications that we have, and pretty much, I want to say the majority of the things that people will have on clusters is either some sort of synchronous nowadays, or at least one-way communication, like gRPC one-way. When you have messaging is where traces get really long in terms of time and start having gaps in them. They are pretty fascinating.
It'll actually be really interesting to instrument faces and see how it behaves, because we do have some. There are some places where I think that we might have some ability to mess with that.
Now, just to give you an idea, this kind of thing gives you a sort of circuit-like understanding of how requests flow through your system. Try to imagine how hard would it be for you to figure out why one particular request failed, having to figure out, looking just at logs, where it went through.
No, I've done that. I don't have to imagine it. It's no fun at all. Okay, so I think at this point, let's go back and talk really briefly about gotchas and see if we might have a little bit of time to actually, Michele, do you have the slides up? You might want to drive this.
I do. Give me a second to click on the right thing. Let's go.
All righty. Gotchas. I think we've talked about these already, but it's good to summarize, right?
So, is linkerd all you need to do distributed tracing to OpenTelemetry? The answer is no, but it helps a lot. As we have discussed earlier, your applications need to collaborate in order to build the traces as they actually happen. If, for example, my application here in the middle, your app 2, were to fail to propagate the trace context between the request it receives from application 1 to the one it issues to application 3, it would create a second trace, and I would have no information that the request I've received on application 3 originated from application 1. Distributed tracing is effectively a sort of Cluedo in which you are following how your requests spread in distributed systems so that you understand how failures in the deepest recesses of your application propagate backwards and how latency builds up backwards. It's no surprise that distributed tracing as a practice has grown in popularity in equal amounts with the amount of distribution in our systems. You start seeing people getting really serious about adopting distributed tracing with microservices, where we actually effectively exploded the complexity in terms of distribution of our applications. If you're running a happy little monolith, you probably don't need distributed tracing. You probably can get along really well with logs and metrics.
It always fascinates me the way people like to talk about microservices applications as if they are not distributed applications.
My God,
and they are, you know.
And it's actually distributed applications in which something that used to be as simple as invoking a function actually
is now a network
hundreds
call.
of thousands of lines of networking stacks.
Yeah.
The point is, it mostly works. So we don't think about the incredible series of miracles that happen when our pictures of cats actually get rendered on the browsers. Now,
hey, pictures of cats are important.
Yes, and I'm happy for those miracles. We said it before, we're being a bit lax with the word of eventually consistent. But effectively, the idea is that tracing, depending on how your applications talk to one another and how they report data of process, they don't appear all at once the way a single log file or a metric data point will. Traces build over time as more and more spans are added to the trace itself. And sometimes, actually most often, you start first receiving traces and spans about the last things that have happened. In case of synchronous communication, the parent span will close after the child does. So it's there is, like, when you look at distributed traces for either traces that are running, especially like I did here, to actually traces that were happening at the time, then you see the tool actually fill in the gaps, fixing the names on the fly, and do a whole bunch of things to improve the understanding of the traces. More data flows in. The another thing that catches people unaware is that traces, technically, you don't know when they're over. You're never going to know if a trace will never again receive a span. If you look at the architecture of your application, you can approximate and say, yeah, that was the last thing that's going to happen. But for example, when you look at tracing with messaging systems and the fact that a message may be consumed multiple times, then you may have traces that are really long and they keep adding more information over time for a very long while. It's always fascinating to see that. And
so we have asked about this the last couple of SMAs. That is a QR code to the survey about Service Mesh Academy. For the love of all that is holy, please go and fill it out and let us know how we're doing and what you think would be better. I'm confident that there are things that everybody thinks would be better about this. Shameless plug, Buoyant Enterprise for Linkerd. It's Linkerd, but it's the enterprise version of Linkerd. It's pretty cool. It's got some neat stuff as on top of what normal Linkerd gives you. Go check it out. Shameless plug also for Dash0. Michele, thank you for joining us. You all got to see Dash0 running. You got to see some of the things that you can find out from it. There's a lot more that it can do that we're going to go through and add some more stuff dealing with Linkerd and things like that. Like ooh, hey, we can have the OTel collector go and grab all the metrics from the Linkerd proxies and make that available in -0, and that would be really cool.
With some really well thought out dashboards that will work out of the box, for example. By the way, I have Casper here in the chat. He's the developer of Dash0. And probably dashboards. Hi, Casper. If you're at KubeCon London, come and say hi. Probably
by all means.
and I will be hanging around and giving talks at each other booth, because why not?
Because why not? Yeah. Buoyant also has various on-demand online courses at learn.buoyant.io. We've got the Service Mesh 101 course, and shameless plug, the Linkerd in production course will be up shortly. Other than that, next month, March 13th, we'll be talking about Gateway API 101. We're sort of kicking off 2025 with trying to go back and talk about some of the basics and the concepts and things like that. So we did Linkerd 101. Now we've done OpenTelemetry from the ground up. We're going to do the Gateway API. I'll be joined there by Gateway API maintainer Shaynut, and maybe with another one or two of the maintainers. That'd be kind of fun. But other than that, I think we have a few more minutes if folks have questions. Otherwise, we'll go ahead and wrap up. But if you do have questions, throw them in whatever chat you have available to you, and we'll see what we can get to. I'm, in the meantime, finishing up answering a question on Slack. Okay. Anything else you wanted to toss out, Michele?
No, it was a pleasure.
Yeah, likewise. It's always fun.
I'm looking forward to KubeCons. Watch it live.
Yeah. It's always fun to do these. It's always fun to dig into something and figure out how it works for the users or how it doesn't work for the users and how we can make it better. Yeah. All right. I am not seeing other stuff show up in the chats. I'm going to give it another maybe minute or so, because sometimes when folks are posting on things that aren't Slack, then it takes a little while to sync over here. I don't know. I didn't really expect that my cluster would act particularly fast in terms of getting spans up to you, but I'm not going to complain.
It was a disappointment. I expected to see much more red to talk about.
Yeah, well,
this is a bummer.
Next time we'll have to slow some stuff down or something.
Pull a plug.
That would be that might be a little disturbing.
I mean, you remember the meme at the beginning, observe of what?
Yeah.
Let's pull one of those.
We'll just put up the dog in the room on fire. This is fine. I see that somebody is typing on Slack, so I'm just going to sit here and wait.
Can you make the human form of the spinning circle for the waiting?
Okay. Kabanaravind, and I apologize for mangling the name, is wondering what other integrations the -0 operator has compared to the OpenTelemetry operator. And, I think we meant to talk about the -0 operator in the beginning and then cleverly failed to put that into the slides.
Yes. So the -0 operator is effectively a sort of reimagined OpenTelemetry operator, which puts ease of use, core, and front and center. It does automated tracing to the extent where you just need to add a custom resource definition to your namespace, and then we will automatically instrument all the Java, Node.js, and later other languages using OpenTelemetry components. The -0 operator is largely built of OpenTelemetry components and -0 opinions. It's meant to be a sort of appliance-like experience for teams and organizations that do not have an existing OpenTelemetry setup and get stuff up and running really fast. If you already have the OpenTelemetry collector going on, the OpenTelemetry operator going on, pointed at Dash0, it's going to work wonderfully. The Dash0 operator is just the quickest way to get you up and running in no time.
Cool.
In terms of integrations, it does a lot of things. It will automatically trace your Java and Node.js applications, collect the logs for them, collect information from the kubelet, so how much memory, CPU your pods are running, collect information from the cluster about your deployments, pod, replica sets, memory limit utilizations, and so on and so forth. It will automatically add a whole bunch of metadata to your applications. So the article that Flynn linked earlier in the talk, all those techniques and more are used in the Dash0 operator to give you the best Kubernetes metadata on your telemetry. This being said, you can enjoy Dash0 without the Dash0 operator. Bring your best OpenTelemetry.
I actually thought it was pretty cool that the configuration to get the hotel collector talking to Dash0 was, what is it, like 2 lines? 3 lines if you count the opening the dictionary. And that was cool.
And actually, that's the beauty of building Dash0 the way we do, based on open standards on the way in and on the way out. All the way that you send us data is through open protocols, no proprietary stuff going on. All the way that you query data is PromQL, including PromQL for traces and logs, which is an experience. It's actually pretty cool. The dashboards in Dash0, you can import Persys dashboards. Persys is a flourishing project, sandbox in the CNCF, for a true open source dashboarding solution, cloud native.
Oh, cool.
The dashboards that you create in Dash0, you can export them, use them in Persys, because we hate vendor locking even when we are the vendor. You don't do that to people. You don't lock them in your walled garden of technologies. It's just, you don't do that.
Cool. All right. And on that note, I think we're going to call it. Thanks, everybody. Much appreciated for having everybody join in and join us for this. Thank you, especially Michele, for coming in and honestly doing most of the work on this one. Really. I mean, I personally really appreciate that.
It was fun.
Thanks, everybody. It was fun. I enjoyed it. We'll do, we'll see what we can talk about again sometime. Have a good one. We'll see you all in